Hello, Matthews Gatos here. Welcome to 6.1 Slope. Let's get started. What is slope? Well, simply put, slope is the steepness of a line. So the bigger the slope, the steeper the line. The smaller the slope, the flatter the line. Now, slope also tells us the direction of the line. Is it going up? Is it going down? Is it a horizontal line? Or is it a vertical line? We can tell what type of a line and the direction of it just by looking at the slope. Let's dig into this a little deeper. So slope is really the vertical change. How much am I changing up and down to the horizontal change? So the ratio of vertical to horizontal change. Now, vertical change is called rise. That's the up and down. Horizontal change is called the run. So I can say slope is rise over run. Now, that rise could be positive or negative. So either I'm going up to get from point to point, which means the slope would be positive, or to get from point to point, I'm going down, in which case the slope would be negative. Now the horizontal change, the run, just like we read a book from left to right, we also read a graph from left to right. So you are always going to run to the right. So when I talk about horizontal change or run, I'm always talking about running to the right. So the positive or the negative for slope comes from the rise. Now we use the letter M to represent slope. You might be asking yourself, why would I use M for slope instead of S? Well, there's been a couple reasons that I've heard over the years. The first reason is we call slope M because it comes from the French word monter, which means to climb. Well, that makes sense. Climbing, rise over run, that makes sense. Another reason I heard is that M stands for modulus because it used to be called the modulus of slope. Modulus just means a constant factor. Well, that also makes sense because slope from point to point stays constant within a certain line segment. So there is no agreed upon reason why letter M is used for slope. So what I like to say is, well, we use M for slope because slope, the word itself, starts with the letter M. That seems to be just as good a reason as any other one. So whatever reason you want to hold on to, let's look at the types of slope. Again, M for slope is rise over run. So the key to this is really remembering we read a graph from left to right. So if you look at this question here, to go from point to point, reading the graph from left to right, I can see that I am going up and then I am going to the right. So since I'm going up and to the right, left to right, to go from point to point, I can say that this graph, this line segment, has a positive slope. Now reading this one here, from left to right, I am going down and to the right. So since I'm going down and to the right, this would have a negative slope. Let's look at these lines here. So in this first one here, again, rise over run. If you read the graph from left to right, you can see there is no rise. I am not going up. I'm actually only going to the right. So I am doing everything on this graph. I'm just running to the right. So since it's 0 over any number itself is 0, I can say that this is 0 slope. Think about that as a ski hill. If that was a ski hill, it would be 0 fun because it's absolutely flat. Let's look at the next one. So in the next one here, reading the graph from left to right, it would really depend on your perspective. You could say that I am rising up from point to point, or you could also correctly say you're rising down. So it could be positive or negative, but that doesn't really matter because there is no run. So if I have any number divided by 0, that's a big no-no in math. In fact, it has a special word called undefined. So this would be an undefined slope. It would be impossible. Just like if that was a ski hill, that would be an impossible ski hill if it was straight up or straight down. So now we've seen the 4 different types of slope that we can have: positive, negative, 0, and undefined. Let's look at how we can actually calculate slope. So we can calculate it on a graph by simply counting. So for example, this line segment AB, if I wanted to count, I know slope is rise over run. Reading it from left to right, I would count the rise. how much am I going up? That's my y value, over how much am I running? That would be a change in my x values. That slope would be positive. And again, positive because I'm going up. In this next example, if I wanted to calculate the slope, again, it's just rise over run. So in this case, reading it from left to right, I would have to go down and then to the right. So down, I would count the difference in my y values. When I go to the right, I would count the difference in my x values. Since I'm going down, this would have a negative slope. So let's try an example with some numbers, okay? Let's say I wanted to figure out the slope of each line segment. So in my first one here, I want to rise. Now, reading the graph from left to right, I know I'm going up. Well, how much up? I'm at -5. So I have to go 1, 2, 3, 4, 5 to get to 0. And I need to get up to another +5. So 1, 2, 3, 4, 5. Altogether, I am rising up 10, +10. Now let's look at the run. I'm at -4 and I want to end up at 2. So I'm at -4. So let's line that up. So I go 1, 2, 3, 4 to get to 0, and then 2 more to get to +2. So altogether I run 6. So my slope would be +10 over 6. But just like any fraction that we work with, we want that to be in lowest terms. So common factor of 2, divide each number by 2, and I get a slope of 5 over 3. Well, what that really means is to go from point to point, I rise 5 and I run 3. Let's look at my next example. Reading the graph from left to right, I can see that I have to go down and to the right. So I know right away that my slope is negative. So rise is the change in y value. So I'm at +2. I have to go down 2 to 0, and then down 2 more to -2. So I am going down 4 units, -4, over the run has to do with my x values. So I'm currently at -4 and I want to end up at +4. So I have to move over 1, 2, 3, 4 to get to 0, and another 4, 1, 2, 3, 4 to get to 4. Altogether, I'm running 8. So my slope is -4 over 8, which in lowest terms is -1/2. So that means to go from point to point on this line segment, I just have to go down 1 over 2, down 1 over 2, and I can generate multiple points that have the same slope on that line segment. A second way we can figure out slope is to use a formula. Now, reading my graph from left to right, I'm using this as my starting point. A is my starting point because I'm reading it from left to right, and this is my ending point. If I want, I can use a formula. So rise is the difference in your y values. So I can just do my end y value minus my begin y value. Run is horizontal. That's the difference in your x values. So I could just do my end x value, x2, subtract my beginning x value. And when I do that, I know that my answer should be positive because that's a positive sloping line segment. Now let's look at the next one. So the next one again, reading my graph from left to right, I am using point C as my start point and point D as my end point. So similarly, I'm going to do rise over run. So rise is the difference in my y values. So I'm going to take my end point, y2, minus my beginning point, y1. And similarly for run, that's the distance between your x values. So end x point, x2, minus the beginning, x1. I know when I do my calculation, I should expect to see a negative slope. So let's try this question with a line segment AB. Now, you might be asking yourself, what if I don't label my points as start and end as I just did? Would I get the same slope? So what I want to try is, let's try it where we do it as, this is my starting point, x1, y1, and this is my ending point, and then we're going to do it in the reverse way just to see if we get the same answer. Okay, so we're going to call this one point 1, and we'll call this one point 2. So into my formula, I'm going to do y2 minus y1. So I'm going to have 4 take away negative 5 over x2, this is x2, minus x1, so minus negative 4. So this would be 4 take away negative 5, 2 negatives make a positive, is 9 over 2 take away negative 4, 2 negatives make a positive, is 6. And then in lowest terms, that would be 3 over 2. Positive slope, yes, that seems reasonable. So to go from point to point, I would go up 3 over 2. But I just want to check it out and see if it would be the same if I flipped those points around. So what if I called this one point 1 and this one point 2? Would I get the same slope? So let's check. So I'm going to do y2 minus y1. So m equals y2 minus y1 over x2 negative 4 minus x1, which is 2. Well, that is just going to be negative 5 take away 4 is negative 9 over negative 4 take away 2 is negative 6. Well, 2 negatives make a positive, so I really know that that is positive 9 over positive 6, which I know from previously in lowest terms is 3 over 2. So it does not matter which one you call point 1 and point 2, as long as whatever point you label as point 1, make sure that's x1 and y1. Whatever point you label as x2 or point 2, make sure you keep that as x2, y2. So it really doesn't matter. So that's comforting. Let's try a question here. So again, it does not matter which one you call which. I'm just going to always stay consistent and read it from left to right. So I'm going to call this one my first point. I'm going to call that one x1, y1. Let's line that up nicely. And then I'm going to call this one point 2, which is x2, y2. So slope m is equal to y2 minus y1. So y2, negative 2, minus y1, positive 2, over x2, 4, minus x1, negative 4. So slope is going to be negative 2, take away 2 is negative 4. 4 take away negative 4 is 8. And in lowest terms, that will be negative 1/2, which seems reasonable because it is a negative sloping line. So to go from point to point, that would just be down 1 and over 2. So again, doesn't matter which point you call which, as long as you remember slope is rise over run, because really you have to rise before you can run. So I hope this video helped, and I look forward to seeing you for the next one.